move to our next talk. Arjun will talk about CAD and GIS in JupyterLab. Arjun is a mentor at PyBAMM project under NumFocus and a contributor to the Jupyter ecosystem on projects such as Jupyter CAD, Jupyter GIS, IPyLeaflet, and much more.
Hello. Thank you all for attending this talk. So I'm Arjun. I would be talking about collaborative and reproducible CAD and GIS in JupyterLab and JupyterLite. So I recently graduated this year only, and I am a scientific software developer at QuantStack now. So let's first discuss the problem. So sharing CAD and GIS workflows is quite painful. Like when you try to share a QGIS file and the other person might have a different version, your QGIS file, like there is 90% chance that your QGIS file would not open and would just throw an error that you are not, you have not seen before, and you are just lost that how do you go ahead. So there is very little reproducibility to no reproducibility, and there is complex UIs. There are a lot of buttons when we talk about either FreeCAD or either QGIS. Like there are 3 rows of buttons and I guess 30 or 40 buttons in the UI, which is quite complex and not beginner friendly at all. And like when we talk about these desktop tools, while installing they can throw very weird errors that like could not install. You would have to just re-download and try to install it again, and they are quite huge, and it can take hours to even download the binaries of these applications. But when it comes to browser native applications, they are like just throw a link and open in the browser, clean UI, collaborative and reproducible. So here comes Jupyter in the picture. So what we do is that we are trying to replicate the experience of QGIS and FreeCAD inside the browser. So Jupyter CAD and Jupyter GIS are CAD and special computing applications built in Jupyter ecosystem inside the browser only. It is also powered by WebAssembly and Jupyter CRDDs, which enables a real-time collaboration. Like you can be sitting anywhere in the world and you can still collaborate like with a colleague that you're working with, like Google Docs. So why does it matter? Why we started to build Jupyter GIS and Jupyter CAD in the first place? Because like science should be shareable, transparent, and reproducible at any point of time. But these desktop workflows are quite fragile and based on the versions and installs and lot of things going on, and you do not know like when you do something in these desktop heavy apps, you do not know what's going in the backend, and if you want to audit these steps, if you want to maybe customize the process a little, you cannot. You would have to go a little much deeper and try to understand what's going on first in the application, and maybe you would just be lost for a while. And when it comes to browser native applications, when it comes to Jupyter specifically, your code is in front of you. You can modify the code and you can just play with it. So there is why browser plus WebAssembly, because it provides a universal runtime. You do not need to install again and again. You just open a URL in your browser and everything works on the fly. And it is beyond CAD and GIS. You can do physics, you can do genomics, like climate analysis and all, and it is language agnostic. So you can be doing CAD or GIS, or you can side by side you can be analyzing the data with Python or R, Julia, or you can be processing the data with any of the language. It is like you can totally connect with any language, and it is totally language agnostic and reproducible workflows because they are notebooks. So yeah, let's first talk about Jupyter CAD. I hope it's nicely visible. So this is Jupyter CAD. Like it is, I have embedded the Jupyter Lite, which is a static application of Jupyter CAD over here, and you can see it working over here. And now we would see what more we can do with Jupyter CAD. So about Jupyter CAD, it is browser native 3D modeling for JupyterLab and Jupyter Lite, and it is built on OpenCascade, which is a 3D engine which does all the processing that goes on in the backend, and it is parametric sketch driven design and integrates with Python code cells as well. So you can create custom sketches like this, and like if I want to create a star, I would just do something like this. I would not create the full star, I would just create this 2 lines and save it. I have this, and I would now extrude it, maybe give it in the 5 and color red. Yeah, as you can see, it has been extruded. It does not look too good, but maybe the next one would be. So you can do Boolean operations and other geometrical operations that you do in FreeCAD or any other CAD application. So if I would add a sphere, and I would like to cut my box with a sphere, so I would just select both of these two and select the option to cut. I would select base as box and tool as sphere and would submit it, and now my box has been cut with the sphere. So you can notice the void that's been created over here, and you can do union, you can do intersection, and similarly you can do fillets and chamfer as well. So I would show you how you can do fillets. So I would select the edges of the box and I would like to make them smoother. So yeah, as you can see, the edges are now smoother. Let's see next. It is a nice example. A box has been cut 8 times maybe with a sphere, and now it looks good. And you can do a lot more. I'm not a CAD expert, that's why I'm just showing very basic things. But yeah, there is this complex model. There we support multiple views. So there is this exploded view. We have this slider. When we enable the button, we have this slider visible, so we can select this and set the exploding factor, and you can see what's going on in your model. It's like every part of the model is has a distance, like is now separated, and you can see what's going on and how and yeah, we also have clip plane. You can it like plays with the visibility of the model when you move this plane. And we also have the wireframe view. If I would just as you can see, if I enable it, I can see the wireframe of the model. Oops. And yeah, so we also support transform control. So as you can see, the pointer of like this point is quite sharp, so I would not like to carry it in my bag, so I would just maybe remove it like this, and now I have a detachable screwdriver. And Python API, it also supports, JupyterCAD also supports Python API. So I would just paste some code, and now you can see the gear has been created. And you can do a lot more with the Python code. With Python you can script models, and you can like this case you can create advanced models as well. And we also support our widget in like rendering inside the notebook only. So as you can see, this model is we are working inside a notebook this time, and we are doing everything inside the notebook. And we have some code. Because we have Python API, so we can interact with the models and set the colors and all the properties and do all the operations with the correct parameters as well. We also, as I have told before, we also support collaborative editing. So these are two users sitting at separate places. So I move the model because the first user is following the second one. You can see that if I'm moving the model, that one is also moving, and if I'm changing the color is also being changed. And we also have suggestion workflow, like how you review PRs and merge, maybe you accept a suggestion or you reject a suggestion. Similarly, you can do it in Jupyter CAD with the models as well. I have created a suggestion for the color of the model, and now if the other user can see that, yeah, someone has created a suggestion, and with the slider he can see that what was the change, and I can accept or reject that suggestion, like how we do in GitHub PRs. And we have because we also are very interoperable, so we support FCSTT file, which is FreeCAD file format. So if you can import a FreeCAD file and you can edit it inside Jupyter CAD, and you can create a Jupyter CAD file and you can export it as FreeCAD. So both works. Like you can if you are working with a person who likes FreeCAD, so you can work with him as well very nicely. And we also support STL files, step files, although we do not support modifying them, but because these files are mostly used in 3D printing, so you can also use JupyterCAD for 3D printing as well. And this is a proof of concept that we are working on right now. We also are going to support JupyterCAD MCP in the future, maybe in a couple of weeks. So you can interact with text and your model will be created. As you can see that I have entered a prompt to create a pawn, and it is trying to do that. It is not perfect right now, and I would just tell him to make it better. So it would try to iterate over it and try to make it better. And again, all of this is real-time collaborative, so even the changes that the MCP is making is also reflected to the other user in the real time. It does not look good, but yeah, it is trying to make it better. So yeah, it is not perfect right now, but maybe okay. So now let's come to Jupyter GIS. Similarly to Jupyter CAD, it is for GIS. Like we are trying to replicate QGIS inside the browser. GIS people, if there is some GIS people over here, they would definitely find it interesting. So about Jupyter GIS, it is a full-featured GIS toolkit inside JupyterLab and also works in JupyterLite, and it supports raster and vector layers, and built on, like, the front end is built on open layers, and the backend, like the processing happens on GDAL, compiled in WebAssembly again. So it has vector and raster data support. The green layer in the back you see is a raster layer, and the dots you see, blue dots you see, are vector layers. I can toggle them. I can toggle the raster layer. I can even toggle the base map that I'm using, and I can also change the opacity and all of any of the layer. And now for the vector data, we also support advanced symbology. So if I would right click on the layer, I can edit the symbology. We support canonical, graduated. If I have color attributes in my data, I can support canonical symbology, graduated, categorized, or heat map. So maybe we can try graduated. So it is an earthquake data, so we would represent the magnitude of the data based upon the color. So I would also select the color ramp, maybe autumn, and I have selected 9 classes with equal intervals, and I would classify. So with a range with equal 9 ranges, it would classify the data, and I would apply it. So now you can see that my data has been like symbolized with graduated symbology, and you also have this nice legends with which you can totally see that what's going on with the representation of your data. And similarly, we also support raster symbology. We have this edit symbology for raster again. We have multi-band symbology. If I would just unset the green band, blue band, and alpha band, no, not alpha band maybe, but so it would maybe should be red. Yes, maybe band 1. Yep, now you can see red. And if I would again select like just give the band to the green one, so it would be green. And similarly, if I give like correct band to each one, it would be black and white, and it would be representing the data that it would want to. We also have single band symbology. We can select the color ramp again and we can apply it. It takes a little bit of time because it is a cloud optimized geotiff, so every time it requests to the server. And but yeah, now you can start to see that layer rendering. Maybe the internet is not so fast, because that's why it's taking time, but yeah, you can see the symbology being changed for the raster data as well. And we like the layers that we load, we have this nice UI for dynamic management of layers. We can toggle the visibility with this icon, and we can drag and drop the layer to change the arrangement of the layers. Like if I move this down, it would be rendered below the NASA GIS layer on the map as well. And if I would just move it up, it would be on top of this. And I can also change opacity on the fly for each and every layer. And yeah, we also have this identify panel. So if I select a layer, this I button I can click on this I button and select any attribute on the map. It shows me what's going on with the attribute, the ID, the magnitude, and it supports multiple attributes at one time. So if I have selected this n number of attributes, I can, and if I would want to see what's going on with this one, I can click on this magnify button icon, and it would highlight that feature while zooming on it. And similarly, it works for the polygons and lines as well. So now I would select some countries. So this is Cameroon, and I must have selected a couple of countries. So yeah, if I click on this again, so it would zoom in and show me all the things that the data have. And we are also going to support the attribute table soon, just like QGIS. And we also have this time slider. If I would select the layer and click on this time slider button, and I can, just a second, click on this time slider button, and maybe I want 4 frames per second, so I can render the data based upon the time, because this data has time value that when the earthquake was hit. And we also have this nice playback button which automatically moves your slider. And we like, just like Jupyter CAD, we provide interoperability on Jupyter GIS as well. We totally support importing and exporting QGIS files. Like we can create Jupyter GIS file and export it as QGIS file, and we can also import a QGIS file inside Jupyter GIS. So if you would see that I exported earthquake files to QGZ, and in some time you would see a file being created below this file. So this is QGC file. I can open that as well. So it would, like, it is a real QGC file. We are not just renaming it. So we also support annotation and collaboration on Jupyter GIS. if I would change the color ramp, it would also reflect to the other user as well. And if I do anything like move the map as well, it would be visible to the other user as well, and people sitting on different parts of the world can collaborate with them. And again, Jupyter GIS is also notebook compatible. I can load a map, I can do everything that I can do on the Jupyter GIS interface inside the notebook as well. And add a layer, we have this nice Python API, which is still work in progress. Like, it has a lot to improve, but yeah, it supports the basic things. And we also have this processing toolbox like QGIS. So if I would click a layer and select this processing, I can do all of this with the layer. I can maybe create buffer. So I have this earthquake data. I want to see that what is the like I would see that on the 10-kilometer radius there is a lot of risk. Maybe I'm not sure about the units, but in the 10 units of the center of the earthquake, all the buildings are in risk. So I would maybe buffer it, and in some time, okay, yeah, now you see that the buffer has been created. So I did it a couple of times, so that's why you see 2 layers, but all the things that are in this radius are in the risk. So, and you can do all of these options that are here. You can do dissolve, centroids, convex help, buffer, bounding box, and everything. And now we use WebAssembly, obviously, PyCRDT and IndexedDB Jupyter extensions, and it not just work inside JupyterLab, it works in JupyterLite setups. WebAssembly enables install pre-use, and it can also be integrated with Jupyter Hub, Voila, JupyterLite, and you can, like, as I have integrated with these slides, I have just used generic iframe of HTML and it works. So coming to the use cases in science, it can serve the climate and land use analysis, or I'm just mentioning some of the examples, but there is a lot that you can do. A reproducible workflow, you can share and reproduce the results anywhere. And the technology, in the technology aspect, we use WebAssembly to like, it can, I guess it never goes old, because if you if you have compiled something to WebAssembly, it would work after quite some time as well. And enables us to use interactive spatial or CAD apps within like static apps within the slides, within any without any heavy backend. Yeah, in like, especially CAD is closely related to engineering. So yeah, and Jupyter is already being used so much in education and in schools. So with the help of Jupyter CAD and Jupyter GIS, it also enables the accessibility for the students and for the teachers as well to easily provide the education about Jupyter CAD and Jupyter GIS. When I was a kid, I did not have enough hardware resources, so I was always short of being able to try these type of applications, but now we can. So if you want to contribute to the project, all types of contributions are welcome. Bug fixes, feedbacks, and everything. And these are the some links. And we have bi-weekly hackathon organized every 2 weeks, and we have weekly catch-ups for the GeoJupyter community. So feel free to join, and feel free to try to like, we would really welcome you in the community. Yeah, thank you. You can try both of these applications live, and yeah, thank you.
We have time for a few questions.
So like the simulations or like animations that you created from CAD and GIS, if we import it on our computer, like, will they be really big files or?
No. So these both of these Jupyter CAD and Jupyter GIS files are purely JSON format. So like, even you can read it without like with human eye as well, you can see what's going on inside a file. Even if there is I showed you a big table in the start when I was showing you the Jupyter CAD demo. So it would be I'm not sure about the size, but it would be very small, very small. The initial file that can you hear me?
Yes.
The initial files that I showed you would be about would be less than 200 lines of JSON. So
Thank
it's
you.
quite lightweight.
Thank
Yeah, so we have been talking internally about integration with cesium, because there is something like open layer cesium, but we are not sure about if we do have enough bandwidth and enough resources to do that right now. But yeah, we do have plans to do that as well. No, everything we create things on plugin based most of the time. So uh, if there's something if we would not definitely like to make open layer cesium required for the application. We would like to it to be like an option. If you like to see that if you like to see your app map in 3D, so you can maybe enable it, or you can we can I am not sure, but maybe we can also create it as a separate extension altogether, so that you can just plug in and play with it as well.
Do we have more questions? Any more questions? Okay. We'll break now for 15 minutes, and we'll start again with the next session at 11:45. Thank you.